Hi guys, welcome to Improve 10x. Today in this session, we are going to learn the basics of inheritance. So inheritance is one of the four pillars of OOPS. Before we deep dive into what inheritance is, let us look at the different things that we are going to learn today. Let us look at the agenda. So first, let's understand the intro about inheritance. Then we are going to understand inheritance with respect to Java. Then we are going to understand the various access specifiers, which are private, default, protected, and public. And finally, we are going to see what is a relationship in inheritance means. So first, let us understand what is inheritance. Inheritance is usually a way of acquiring the properties and behaviors of a class when it comes to programming. So before we go for any further, let us understand the terminology here. Whenever we say a superclass, the superclass is nothing but the parent class from which the properties and behaviors are inherited. Similarly, we also have a subclass. Subclass is nothing but a child class to which the properties and behaviors are inherited. So as you can see in this picture, whenever we wanted to inherit the properties of class A into class B, then we are going to use inheritance. And that is represented by this arrow notation. It is a UML notation. Let us go and check another example of a Temple Run game. In Temple Run, there are multiple characters. As you can see in this picture, there are coins, there are obstacles. We can break down this into something that you are looking in this particular slide. For example, if we create a superclass called character, then we can create a subclass called player, which is extending from this superclass. So this player has all the behavior and the properties of this character class. In addition to that, it will have its own behavior. Similarly, we can also see there is an obstacle superclass. From the obstacle superclass, there are three different classes that are being inherited. You can see the fireball obstacle, then there is a spike pit, and there's also a coin. So for example, if the player collects a coin, then the behavior is different. So the score should increase, right? Similarly, if the player collides a fireball or a spike pit, what happens? The energy of the player will go down. Similarly, the obstacle is a generic class, but when it comes to the implementation of a specific kind of obstacle, it is becoming specialized. So fireball, spike pit, and coin are the subclasses of this particular obstacle superclass. Now, let us go back to Java once again and understand how class inheritance exists in Java. Throwable is the superclass or the parent class of all the exceptions and errors. So if you can see in this slide, throwable is at the top of the hierarchy, which is the superclass of exception. From exception, there are multiple subclasses like IO exception, class not found, runtime exception, clone not supported exception, etc. So from IO exception, there are multiple files or exceptions that are being inherited. Similarly, from runtime exception, you can see there are more than 8 classes or 8 exceptions that have been inherited. For example, there is null pointer exception, which we usually encounter during the coding or the programming of any particular problem, right? Similarly, index out of bounds exception is faced when there is when we are dealing with arrays. And similarly, arithmetic exception when we try to do some invalid or illegal arithmetic operation. So these are the exceptions that are generated when exception occurs in the program. So this is the hierarchy of exceptions class in Java. So all the common methods that are, for example, get message or print stack trace, these methods are usually written in the throwable class And these methods are inherited down this particular hierarchy. So not only Java supports class inheritance, but it also supports interface inheritance. So the example for this is the collections hierarchy. In the collections hierarchy, iterable is the interface that is at the top level, which is, you can call it as a super interface because it's not a class. Yeah, super interface. And then from iterable, we have a sub interface, which is collection. From collection, we have list, queue, and set. Similarly, DQ is the interface that is extending from queue, and sorted set is the interface that is extending from the set interface. So, to enable inheritance in Java, we use the keyword called extends. Also, we are going to discuss different access modifiers and how it is going to affect the accessibility of a particular property or a method. Whenever the properties and the methods are private, then only the superclass can access them. Subclasses will not have any access to the private properties and methods of the superclass. Now, extending it forward, there is default. Default is nothing but not having a particular access specifier in place. So whenever the properties and the behaviors are declared as default, then they can be accessed by the subclasses, but within the same package. Similarly, we have protected. Whenever the access modifier protected is used in front of any method or property, those can be accessed within the class and also by the subclasses which are in different package. And finally, we have public. So all the variables and the methods which are declared as public are accessed by all the other classes within the project. Now, let us go ahead and see an example of inheritance. Let us practice it. This is what we are going to create in our project, and we are going to run the game and see how it is working. So initially, as you can see in this slide, we need a character class. So let's go ahead, create a new class. Called character. Right? Yeah. So once we have the character class, let us define the various properties that a character in a game can have. So the first name is why other side? Okay, it's a little slow, I guess. Yeah, public string name. Then also any character would have a health, right? Because the health of 100 means it's fine. A health of 0 means that the player is no longer alive, or you can say that the game has ended. So let us maintain a variable, and I'm intentionally putting all the access modifiers as public. We will see what is the reason for that and how we can modify it later. Yeah. Right. So we have two properties by name and health, and let us generate a constructor. So I'm generating a constructor which takes 2 parameters. And once this is done, I am also generating the getters and setters for both the properties. Okay. And whenever a particular obstacle hits this particular character, the health should reduce. So that is the reason I am writing another method called reduce health. So whenever there is an injury, that is when the health reduces. So the input to this is you can consider as the amount of damage or the damage quotient that is being done to the health. So from this health, what I am going to do is I am going to remove this damage quotient. Done. So I think we are all done with the character class. Now, let us go back to the slide and see which class is extending from the character class. So it is a player class. So let's go back and create a new class, which is player, which extends from character class. I'm zooming in a bit. Yeah, so this extends the character class. Done. So what does the player need, guys? I think the score is something which is needed for a player. So we can do private int score. And let us generate the constructor. So create constructor matching super. And once the super, so super is usually the first statement in any method. So in this particular constructor, the constructor of the super class is called by using the super keyword in line number 8. So whenever this super of name comma health is called, it refers to the constructor in the character class. Fine. Now, once we call the super constructor, we will simply assign the score or initialize the score to 0, right? Whenever we create an instance of a player, we will initialize it to 0. Now, next, what are the actions of this player? Usually the actions are running, jumping, right? So let's create few methods which says run, and I'm just going to add a print statement here which says running. Now let us go ahead and create another method which is jump. So in the jump method also, I am so when is the player going to jump, guys? Whenever there is a obstacle, isn't it? So what I'm going to write is I'm going to add a simple print statement, and I will say so there is name, right? This the name of the character, and jumped to avoid obstacle. Does it make sense? Obstacles. Done. So the jump method is also complete. Then we also have a score, right? So I am generating a getter for score, which will return the score variable. And also the player can collect points. So I'll write another method where he is going to collect coins. So usually coin is sent as the parameter, isn't it? And whatever score is there, that should get updated with this coin value. So coin dot something like get value, which we are going to fill up once we have the coin class. Done. So yeah, I hope the implementation for the player is done. Now let us go back to the slide and let's create obstacle superclass. So I am just creating a new Java class called obstacle. And in this obstacle, what are the main features of this obstacle class? So obstacle is nothing but some inhibition, right, or which interferes with the player, right? So it's going to do some damage as well. So first of all, since there are different kinds of obstacle, let us give a name to each one of it. So public string name, and we also have public int damage quotient because this is the damage that is done. Then let us generate a constructor. Okay, and usually the obstacles will collide. So let us have a method which says collide. And whom will it collide? Usually it's a character. So I'm taking a character object as input parameter and giving a small print statement. So this particular obstacle has collided with the character's name, right? So character dot get name, we have a getter for that, and also there is a certain damage that's been done, isn't it? So we're going to write and caused this amount of damage. So let us append the damage variable and text as damage. Done. Once the collision happens with the character, also the health of this particular character reduces. So character dot, let us call reduce health with this damage as input. Done. So the obstacle class is ready. Now let's go back to the slide and let us create a subclass of obstacle, which is a fireball. So again, going back to the project, let us create a new Java class which says fireball, and this is extending from obstacle class, right? So are there any specific properties for this moving fireball? Yeah, definitely. There is speed, right? So we can declare that particular variable speed, and let us have a constructor for this, which takes the input parameter speed. So how do I write the constructor? Public fireball, and let us take int speed, and let's call the super class first, and I'm passing the name as moving fireball, and it also expects a second parameter, which is the damage. So I'm assuming, or I'm just taking 30 as a damage, for instance, and I'm also setting up the speed to the parameter that is passed. Done. What else can a fireball do? It can roll. So let us create another method called roll, and I'll just give a print statement saying that the fireball is being rolling with. So println the name is rolling with speed of whichever speed we have, and you can give some units like miles per hour or kilometers per hour, etc. Done. And is anything else getting affected? I think that's it. Now we can wrap up the fireball class. Then if we go back to the slide, the next one that we need to create is a spike pit. So a spike pit also extends from the obstacle class. So let's go ahead, create a new class called spike pit, which is extending from the obstacle class. Now, so a spike pit has a width, right? So private int width is the variable that I'm going to declare. And after that, I am going to generate a constructor, or I'll just write a constructor which it takes this width as the parameter. And let me call the super constructor first. which is expecting the name. So I'm passing it as spike bit. And the damage, let us assume 50 as the damage, and whatever width we are passing in the parameter, I'm assigning to the width variable here. Done, the width property. Now this, once this is done, what can happen in a spike bit? So once a character gets collided with a spike bit, so he will get trapped. So let us have a method called trap, and this is going to take a character, right? And how is the character being affected? So you can simply write a print statement to reflect the same. You can say this particular name. So it will be like spike bit trapped the character's name. And inside, some sentence that makes sense. There is also a width. So you can say inside, and it is so and so meters wide, etc. So you can say it is width and then meters wide. Done. Also you need to reduce the health, because once the character is trapped, the energy or the health will get affected. So you can simply say this character dot reduce health, and you can send this damage quotient inside. Okay, now we are done with the spike bit also. The next obstacle that we are going to implement is the coin. So coin also is an obstacle, but whenever a coin confronts with this particular character, it increases the score of the character. So that is the reason we are adding a coin as well. So once we have a coin class, what is the property that a coin can have? It will definitely have a value. So let us go ahead and write the property value, and let us also write a constructor wherein it is going to take value as the parameter, and let's call the super constructor. So here the name is coin, and the damage is 0, right? The coin doesn't do any damage, so we are going to initialize it to 0. So here we did not extend the coin class, so which we have to do. So I'm adding extends obstacle. Once this is done, I will simply update the value as well. Okay, and let me write a getter for the value as well. Let me go ahead and generate the getter for value. Okay, done. So yeah, I think we have completed the coin class as well. Now if we go here, so whenever the player collects coins, then the coin value will be added to the score of the player. Done. So we have implemented all these particular classes: character, player, obstacle, fireball, spike pit, and also the coin. Now what is pending is that we have to create a game class, right? Where we can actually run. So let me go ahead, create a new class. I will say temple run game. So this is our main class from where the execution starts. So I'm adding a main method. So the first step is to create an instance of player class. So new player. So it is expecting 2 parameters, name and the health. So I am initializing the name to adventurer, and the health is initially full, so I am giving it as 100. Now once the player is initialized, we can go ahead and declare an array to save the coin values basically. So I'm going ahead and declaring some coin values like 10, 20, 30, 40 and 50, some 5 coins. So I have added the coin values into an array. So whenever the player collects the coin, the value of that particular coin is added to his score. Next, we need a boolean to say whether the game is running or not. So is game running? And I'm initializing it to true. Then I'm using a random class to randomly uh, pick up any particular obstacle. So since we have 3 obstacles in our game, this random class is going to pick any of these obstacles randomly. So I'm writing a print statement that says Temple Run game started, or welcome to Temple Run. Done. So I'm starting a while loop wherein if is game running is true, then what I'm going to do. So first thing is the player must be running. So I'll call player.run. Then I have an obstacle type. So I want to get the obstacle type based on this random integer that's being generated. I'm creating an int obstacle type and I'm calling this random.nextInt, and the boundaries are, the bound is 3 because there are 3 obstacles that can be generated. One is moving fireball, the other is spike pit, and the other one is coin. Now, if that obstacle type is 1, then let me go ahead and create an object of this fireball. So fireball is equal to new fireball, and it is speed was what is expected. So the speed also I am going to randomly generate. Let me take 30 so that any speed from 1 to 30, and I'll just add 10 to it, right? Next, once the fireball object is ready, I can simply roll the fireball, and also I can collide with this particular character, right? Fireball dot collide, and I am passing this player. Done. So this is when the obstacle type is fireball. Else, let us consider if the obstacle type is 2, an object of spike pit this time. So new spike pit. For a spike pit, we need to pass width, right? So again, I am going to use random with bound, let us say some 10 as the boundary value. So anything between 0 to 10 can be generated, and I'll be adding +5. So it is so many meters, and the spike pit dot, we can call trap method, and I'm passing the player. Right. Yeah, this is done. So else, which means it's number 3, which is obstacle type is 3. Then I am going to create an object of coin class. So before going ahead and creating a new coin, let me also, I need to decide which coin, because I have 5 different coin values, right? 10, 20, 30, 40, 50 are the different coin values. So I need to pick one coin. So for that reason, again, I am going to use random index value out of the available indices. So random dot nextInt, and the boundary is this time coins value dot length. Done. Once this is done, I will simply call coins value dot this of random index value. So for example, if random index value 4 has been generated, so index value of 4 is nothing but 50. So 50 will be added to the score value, right? Once we call collect points. Done. Coin object can be passed. Suppose if the player health has deteriorated, which means it has gone below zero, right? When an obstacle it's collided, the health of the player is getting reduced. So if that health is lesser than or equal to zero, it means that game is over, right? So let me just print out that statement saying your game is over, game over. And probably we can also print out the final score, right? So we have this method, which is player dot get score. This is done. So yeah, the score also is printed, and we should also make the game stop. So I'm setting the is game running boolean value to false. I am calling thread.sleep method, which will kind of pause for so many milliseconds, which is 1 second, and call the sleep method, right? Done. So yeah, all good. So let us go ahead and run this particular project. Okay, now you can see welcome to temple run running. The fireball is rolling with a speed of 18 miles per hour. A fireball has collided with the adventurer and caused 30 damage. So initial health was 100, now it becomes 70. Again is running. Again a fireball has been triggered, again causing a damage of 30. So now the health of the player is 100 minus 60, which is 40. Next, running. Again, the fireball has been triggered. This time again 30. So 40 minus 30 is 10. Again, he keeps on running. Now the spike pit has come up, so which is 7 meters wide. So 10. So the health of the player is only 10, and the health has become 0 in the last step because he got trapped in the spike pit. So the game is over, and the final score is 90. We can add a print statement. Collected so many coins, right? Collected coin of value, coin.get value. Player is inheriting from character. Similarly, fireball, spike pit, and coin are the classes, subclasses of obstacle class. Now, let us understand, since the name and health in this character class are public, it is available to all the classes within this project. But if we want to restrict them to be available for only the subclasses, we are going to modify it to protected. Right? So now the player class, which is inheriting from the character class, will still be able to access name and health. As you can see, there are no errors, because we have to make sure that the properties and the variables are safe always. And whenever we declare them as public, it is, since it is available or they're accessible by anybody within that project, it is always not secure. That is the reason we have to open up the gates only as much as needed. So that is a reason we are putting this name and damage and whatever attributes we want to be inherited as protected. The remaining values to private, for example, coin, and then we have speed. So let's change back to private. Similarly, in player, we have a score which is already private. Then we have width which is private. Yeah. So that we are giving only the minimum amount of accessibility to these particular variables. Done. Okay, so this is how we have implemented inheritance using the extends keyword, as you can see in Java. Since player is a character, we are able to pass player. So Any in this slide we are saying that player is a character. Similarly, fireball is an obstacle, spike pit is an obstacle, and coin also is an obstacle. So wherever there is a reference to the superclass, any subclass can simply replace that particular object. That's it for today's video, guys. Let us catch in the next video in part 2, inheritance, where we are going to learn more about inheritance and how we are going to use it in different projects, etc. So thank you. See you in the next video.